Okay, this video is about how to write electron configurations, then determine the number of valence electrons, and then to draw the dot symbol. Okay, so I guess I should have typed this out on the document, but the valence electrons, let me see if I can get this to work here. All right, so the valence electrons, I'm going to abbreviate that VE. Okay, those are the electrons in the highest, and here's a keyword, numbered energy level. Okay, that's an important thing. All right, so anyway, the first thing that you got to do before you can figure out the valence electrons is to write the electron configuration. So for lithium, it's going to be 1s2, 2s1. That's it. Three electrons, 2 plus 1 is 3. All right, now to figure out the valence electrons, we got to find the highest energy level. So is it 1 or 2? Well, it's energy level number 2. And we got to count how many electrons are in energy level number 2. And there's only 1. So it has 1, lithium has 1 valence electron. So to draw the dot symbol, you just write the element like you would like lithium. You just draw lithium. And then what you're going to do is you're going to show a dot that represents the number, the valence electron, or the number of valence electrons. Now there's all different kinds of rules for like how to show these dots. Some books or some websites say to do it one way, some say to do it the other. So I prefer, and I'll show you when we get to a harder one, but that you just start at the top and put your dot. And we'll talk about this, but the maximum number of dots can be 2 per side of the element. I'll show you that when we get to one that has more than 1 dot. All right, so let's go to carbon. Okay, so carbon is 1s2, 2s2, 2p2. 2, 4, 6. Carbon's number is 6, so that adds up. Okay, let's get the valence electrons. So first of all, we got to find the highest energy level. Now the energy level is number 2. Remember the big numbers stand for energy level. Okay, so we have to add up all the electrons in the highest energy level. So 2 plus 2 is 4. So carbon has 4 valence electrons. Now, to draw the dot symbol, you might come across in a book that says, oh, you always got to pair electrons up or something like that. But I don't like to do it that way for bonding reasons later on. So anyway, we have to show 4 dots. Okay, the only rule is that you can only have a maximum of 2 dots per side of the element. So let's just look at the sides. So like let's pretend we have this side, this side, this side, and this side. The rule is you can only show 2 dots per side. Now since carbon has 4 dots we got to show, I prefer to just show it like this. 1, 2, 3, 4. Some textbooks will say, hey, you got to put them in pairs like that. Okay, it doesn't really matter, but the rule is you can only have 2 per side. If you pair them up, that's okay. If you have 1, 2, 3, 4, that's okay. I prefer it this way for something I'm going to teach you later on, but you can do it either way. All right. Okay, now let's do argon. All right, now argon's kind of getting down there a little ways. It's number 18. I could write it the long way. Okay, let me just do that quick. 1s2, 2s2, 2p6, 3s2, 3p6, and that would be it. Okay, and so that's 18 electrons. Now, you could do it the shorthand way. The shorthand way is to put the noble gases in brackets and then go from there. However, it would be incorrect to put just argon in brackets. You can't do it that way, even though it's a noble gas. All right? what you got to do is you got to back up from argon, all right? And so to the nearest noble gas, and argon's nearest noble gas, if you look at a periodic table, is neon. So you would have to put neon in brackets. That means neon's electron configuration, which is this all the way to 2p6 thing right here. And then you would just go from neon, 3s2, 3p6. Okay, that's the shorthand way for argon. Now, to find the valence electrons, you can get it from the shorthand way or the long way. But anyway, we have to find the highest numbered energy level. Well, that's 3. And so if we count the total number of electrons at energy level number 3, that happens to be 6 plus 2 is 8. So it has 8 electrons. Okay, so to draw the dot symbols for argon, or the symbol for argon, is you can put 2 per side. You got to show a total of 8, a maximum of 2 per side. Okay, now a couple more here. Magnesium. All right, let's see here. So I could write it the long way. 1s2, 2s2, 2p6, 3s2. Or I could write it the shorthand way and just put, if you back up from magnesium, the nearest noble gas to magnesium, counting backwards on the periodic table, is neon. And so it would be neon 3s2. All right. Anyway, the valence electrons, you find the highest numbered energy level, which is energy level number 3. And then you count how many electrons. That's 2. So magnesium would have 2 valence electrons. 1, 2. Okay, now iron is kind of a tricky one, so pay attention here. All right, I'm going to write it out the long way just for a reason here. So here we go, iron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, if I count 1, 2, 3, 4, 5, 6. All right, now iron is, I could also show it if I want to do the shorthand method. So if you back up to the nearest noble gas from iron, it's argon. So I put argon in brackets, which means everything like up until 3p6. And then you go 4s2, 3d6. All right, now how many valence electrons does this iron have? Okay, well, the thing is, you got to go to the highest numbered energy level. So what number is higher, 4 or 3? And the answer is 4. How many electrons are in the 4th energy level in iron? Well, you just count 4s2, that's 2 electrons. So iron would have 2 valence electrons. 1, 2. That's the dot symbol. All right, now I think you can finish the rest of this document on your own, but I want to show you kind of a little trick that you can look at here. And so if you want to go to periodic table, it's just go to periodictable.com. You could see this. And if you click on electrons, let's say, if you click on electrons on the periodic table, it shows you, like you can click on any element, and it shows you the orbital notation, the electron configuration. But I want to show you something here. Let's start with hydrogen. If you look at hydrogen, then go to lithium. I want you to count how many valence electrons are in hydrogen. Well, it has 1. Lithium has 1. Sodium has 1. Potassium has 1. Rubidium has 1. Cesium has 1. This francium has 1. Everything has 1 in group 1. I call it group 1A here. Everything has 1. In group 2, now helium's put over here, but if we look at group 2, everything has 2. Go all the way down in a column. Everything has 2 valence electrons. All the way down. Okay, let's skip the middle ones now, but let's go over here to the boron group. I like to call this one group 3A. But if you look at boron, if you look at the 2p and the 2s, that's a total of 3 electrons. Aluminum, 3s, 3p, that's 3 valence electrons. Gallium, Uh, let's see here. What's it doing here? Yeah, gallium 4s2, 4p1. That's 3. Indium 3. Everything in this column, the boron, aluminum, they all have 3 valence electrons. Carbon, the carbon group, guess what? Everything has 4. Silicon has 4. Germanium has 4. Tin has 4. Lead has 4. Everything has 4 in that column. In the nitrogen column, everything has 5, if you count them up. Phosphorus has 5 valence electrons. Arsenic has 5. Antimony has 5. Bismuth has 5. I can't pronounce these down here, so I'll skip those. All right, oxygen. The oxygen group, okay? Everything has 6. Like sulfur has 6 valence electrons. Selenium has 6. All these have 6. The fluorine group, all have 7. If you count all the way down, they have 7 valence electrons. The last group over here, the noble gases, all have 8, except for helium, which has 2, which they put it over here just to make it line up with that group. All right, that's an easy way to get valence electrons. Okay, what you need to do is to complete this document, and then hopefully you'll get the hang of it after doing this. That's it.